So this is the key for the acceleration problems. So the formula for acceleration is the change in velocity over the time. So you're going to do, for the change, you always subtract. You're going to do your final velocity minus the initial velocity divided by the time it takes. Okay, and just make sure that you're showing your work for this assignment. If you don't show your work, I'm going to deduct points. Okay, so make sure you're showing your work. So the first problem, Natalie accelerates her skateboard along a straight path from 0 meters per second to positive 4 meters per second in 2.5 seconds. Find her average acceleration. So acceleration is the final velocity. What she ended at was 4. Her initial was 0. You're going to subtract those, and then you're going to divide that by the time, which was 2.5 seconds. So 4 minus 0 is 4. So 4 divided by 2.5 is 1.6 meters per second squared. But remember that acceleration is a vector. So you have to put the positive sign on it. So make sure you put the positive sign in your answer. Positive 1.6 meters per second squared. Remember, the units for acceleration are meters per second squared, because you're doing velocity divided by time. Velocity is already meters per second, and so you're doing meters per second divided by seconds. So it's going to be meters per second squared. Okay, number 2, find the average acceleration of a northbound subway train that slows down from positive 12 meters per second to positive 9 meters per second in 0.8 seconds. So you're going to do your final velocity, which was 9.6. That's what they ended at, minus the initial velocity. So 12 was the initial velocity. So make sure you're subtracting this here. Yes, you're going to get a negative number, and yes, that is okay. So you want to do 9.6 minus 12. It's not always big minus small. If you're slowing down, you're going from a higher velocity down to a lower velocity. So when you subtract those, you should get a negative number. Divided by the time was 0.8 seconds. So you're going to get negative 2.4 when you subtract. Divided by 0.8 is going to give you negative 3 meters per second squared. Okay, so negative 3 meters per second squared. Number 3, a roller coaster rapidly picks up speed as it rolls down a hill. As it starts down the hill, its velocity is positive 4 meters per second. But 3 seconds later at the bottom of the hill, its velocity is positive 22 meters per second. What is its average acceleration? So again, acceleration, you're going to do the final velocity, which was 22, down the hill, minus the initial velocity at the top of the hill, which was 4, divided by the time, which was 3 seconds. So 22 minus 4 is 18, divided by 3 is positive 6 meters per second squared. Make sure you have the positive sign on there. Number 4, a cyclist travels at a constant velocity of 4.5 meters per second westward, and then takes 5 seconds to speed up to a velocity of 12 meters per second, still traveling westward. Calculate the cyclist's acceleration. And really, this should not be positive. This should be westward, because they specified westward in the problem. So we're going to make sure we put that, correct that mistake. There we go. Okay, so westward on that one. So you want to do your final minus your initial. So 12 is the final velocity, 4.5 is the initial velocity, and 5 seconds was the time. So 12 minus 4.5 is 7.5. 7.5 divided by 5 is 1.5 meters per second squared, and then the direction would be westward. As a shuttle bus comes to a normal stop, it slows down from positive 9 meters per second to 0 meters per second in 5 seconds. Find the average acceleration of the bus. So your final velocity is 0 because it's coming to a stop. It started out at 9. So 0 minus 9 is going to give you negative 9. Okay, so negative 9 divided by the time, which was 5 seconds, is going to be negative 1.8 meters per second squared. Okay. All right. Number 6, assuming the ball started at rest, determine the acceleration of the ball as it rolled from position A to position B in 1.5 meters, in 1.5 seconds, and had a final velocity of positive 4 meters per second. And so I made this part started at rest in red because that's very important. If it starts at rest, that means it's starting at 0 meters per second. That's its initial velocity. So your final velocity is 4, your initial is 0. So you're going to do 4 minus 0, okay, divided by 1.5, that's the time, equals 4 divided by 1.5, and that's positive 2.67 meters per second squared. So you actually didn't even need this picture at all. You don't need the picture because they give you the velocities in the problem, and you don't need to worry about the distance. So you really don't even need that picture at all. So your answer is positive 2.67 meters per second squared. Okay. Number 7, what is the acceleration of a car that travels in a straight line at a constant speed? Acceleration is 0. Because there is no change in velocity if it's a constant speed, and there's no change in direction if it's going in a straight line. So there's no acceleration. Number 8, Josh skates in a straight line at a constant speed for 1 minute, then begins going in circles at the same rate of speed, and then finally begins to increase speed. When is he accelerating? Explain your answer. So Josh is accelerating whenever there is a change in velocity or direction. So that means when he's going in circles, he's changing his direction. So he's accelerating there. And then when he increases the speed, he's accelerating there because he's changing his velocity. Okay, he's going to be increasing his speed. So in circles and then increasing speed are the 2 times he is accelerating. Number 9, an object is not accelerating in the scientific sense when it A, speeds up, B, slows down, C, changes direction, or D, moves in a straight line with a constant velocity. And so the only time it's not accelerating is if you're going in a straight line with a constant velocity. That's D for number 9. Okay, a race car is traveling around an oval track at a constant speed. At which point on the oval track does the race car accelerate? See the figure to the right. So A is showing a straight path, B is showing a straight path, and C is showing a corner where you're going to be changing your direction. Now he's going around the track at a constant speed. So that means in the straight tracks, the straight parts of the track, he is not accelerating. He is only going to be accelerating when he changes direction. And so point C is going to be your answer for number 10.